Hey guys, welcome back to my channel, Krazy in the house. It's been a long time since I uploaded the last video because I was running exams in the school, so I'm back with the bang. And now, today I'm going to be dealing with the topic atomic structure in chemistry. So let's go. Now picture this as a sheet of platinum taken by me. So now platinum, as we all know, its symbol is PT. So basically platinum is made up of tiny molecules of platinum. Each exhibit the same properties as the platinum as a whole. So now each molecule is also consisting of some other fundamental particles, or the basic particles called atoms. Now let us say that these are the atoms of platinum. Now the idea of tiniest unit of matter, that is anu or molecule and paramanu or atom, was propounded by Maharshi Kanada in Vedic period in India. Later, a Greek philosopher, Democritus, also proposed that matter is made up of extremely small particles, the atoms. The name atom comes from the Greek language, meaning indivisible. John Dalton in 1808 published Theory of Atom, assuming that atoms are the ultimate indivisible particles of matter. Later, the works of William Crookes 1878, J.J. Thomson 1897, and Goldstein proved that atom of any element contains smaller particles which are either positively charged or negatively charged. Works of Rutherford and Niels Bohr confirm that an atom consists of three subatomic particles, electrons, protons, and neutrons, respectively. Let's talk about Dalton's atomic theory. First up, he told that atoms were indivisible and that there was nothing to, take out from atoms. Now let's go to the next law or theory that he insisted on. He told that they were different. It means that atoms of different elements were different in all respects. And also the third one is that atoms of same element are same in all respects. Next up, he told that atoms combined in small whole number ratios to form compound atoms or molecules. He also told that the atom was the smallest unit of matter that take part in a chemical reaction. This is a view of the modern atomic theory. Now let's talk about the discovery of cathode rays or electrons. The cathode rays were discovered by William Crookes in 1878. This was the apparatus used for the detection or discovery of cathode rays. Basically, this is the induction coil. This is a switch and a battery, and these are the wires connected to a discharge tube. The gas here present in this has a very low pressure of 0.01 millimeter of mercury or Hg. So this is the negative terminal which is connected inside the discharge tube, and this is the positive terminal. Now, as you can see, it is not complete as they are not both connected. So when the pressure of the gas is at 0.01 mm and the voltage of the battery is about, I think, 10,000 volts, then something amazing happens. the zinc sulfide screen present here started to glow when the circuit was switched on. Even though there was some distance between them, it started glowing. It was assumed that some invisible rays were emitted from the zinc sulfide screen, which made it glow. More experiments proved that the cathode does not give out invisible radiations. Actually, tiny particles present in the zinc sulfide moved from the cathode towards the anode. These particles were named electrons. The electrons, on striking the screen, made it glow. Later, it was found that electrons had a definite mass and definite electrical charge, which is negative in nature. The mass and charge of electrons was same, irrespective of the nature of gas within the discharge tube. The conclusions of this experiment were: the electrons are an integral part of all atoms which are negatively charged. Next, since atoms are electrically neutral, therefore an atom must contain another kind of particles which are positively charged, and they named it as protons. Now, the total negative charge on the electrons of an atom must be equal to the total positive charge on the protons. Now let us talk about the characteristics of electrons. The charge on one electron equals minus 1.6 into 10 power minus 19 coulombs. The mass of one electron equals 9.1 into 10 power minus 31 kg, which equals 1 by 1837 times the mass of one hydrogen atom. This is a similar setting to the previous one, but instead here is a perforated cathode, and the zinc sulfide screens are placed on either sides, and there's the battery, the switch, the coil, the anode and the cathode, and this is the discharge tube in which the gas is present, and at the similar conditions as provided in the previous experiment. Goldstein is credited with the discovery of protons, the positively charged particles. He reasoned that if electrons are knocked out from a gas at low pressure, then there must be some residual positively charged particles left. The particles must move towards cathode and get discharged there. However, if the cathode is perforated, then some of the particles must pass through the cathode and hit the zinc sulfide screen. These particles could be detected by the screen, on which they will cause scintillations. When high voltage electric discharge was passed through the discharge tube, the scintillations were produced on the screen, as expected by Goldstein. These scintillations were due to positively charged particles. Further, experiments were conducted on these positively charged particles. Following are the characteristics on these particles. Now these are the characteristics of protons. The charge of a proton is 1.6 into 10 power minus 19 coulombs. The mass of the proton is 1.67 into 10 power minus 24 grams, or 1.67 into 10 power minus 27 kg. Next up, let's talk about the discovery of the nucleus. Rutherford set up the following experiment. Now, he reasoned that if positively charged mass present within the atom is thinly spread, then any positively charged particle moving with sufficient kinetic energy would easily penetrate through it. This is a gold foil that is very thin. If a thin gold foil is exposed to fast-moving positively charged particles, then the particles would just pass through it, right? Now these particles could be detected by a zinc sulfide screen, which is circular in nature. Now it is placed behind the gold foil, and when the scintillations shall be produced by the zinc sulfide screen, then we would know if they would pass without going straight or deflecting and all that stuff. This was just expected that they would not be deflected much, but later, after the experiment, Rutherford, to his surprise, saw that some of the scintillations were produced in regions that would not have gotten there. He wouldn't have expected, he wouldn't have assumed them to go there, but it was so seen. Now this can be explained only if we assume that positive charge in atoms is not thinly spread, but is concentrated at a very small place in the atom. Now this small place was called nucleus later on, but when alpha particles approached the gold foil, they deflected almost through 360 degrees. However, if they pass very close to concentrated positive mass, they get deflected through large angles. Later, the following conclusions were made. It was concluded that atom is empty. Positive charge is concentrated at some point in the atom, and the angle of deflection depends upon the angle at which the alpha particles strike the positive mass in the atom. Moving on, the next topic is the discovery of neutrons. When measured, the atomic mass of an element should be equal to the mass of its protons. The massive total number of protons was far less than the atomic mass calculated experimentally. So it was concluded that within the nucleus some particles were present having same mass as protons but no electric charge. They were named as neutrons. In 1932, Chadwick discovered the neutrons, and also some other particles like mesons and neutrinos and quarks were later discovered. The atomic number denoted by the letter Z is the number of protons present in the nucleus of an atom. It is believed that the chemical properties of an element are controlled by its atomic number of an element. It was later observed that the atomic number was equal to the number of protons and also equal to the number of electrons in most cases. The total number of neutrons and protons present in the nucleus of an atom is called its mass number, denoted by the letter A. This is equal to the atomic number plus number of neutrons. Yep. Next up, let's talk about the Bohr-Bury scheme of electronic configuration. The modern theories of atomic structures were in this way. The protons and neutrons, collectively called the nucleons, present in the nucleus at the center of the atom, and the electrons revolving around the nucleus in different orbits or shells or energy levels. Now, this scheme is pretty simple. Basically, it helps to easily find out the maximum number of electrons in each shell or energy level or orbit. The formula 2n squared was used, where n is the number of shells or electrons. For the first shell, the name is K shell, and it is 2n squared, so 2 into 1 square and 2 electrons. Now, for the second shell, that is the L shell, this formula 2n squared also is applied. Now 2 into 2 squared 2 into 4 and 8 electrons, and so on. For the third shell it is 18 electrons, and the fourth shell it is 32 electrons. Thank you all for watching. Like, share and subscribe if you enjoyed it, and I'll see you guys in the next video. Peace.